Hello NEET aspirants, I hope you all are doing great. So welcome back to this channel and myself Madhu Yadav. I am a senior lecturer for Zoology at Sri Chaitanya Goshala. So today my topic of discussion is transport of gases, which belongs to the chapter breathing and exchange of gases. In my previous lectures, I have discussed the mechanism of exchange of gases, right? So there you can understand how the exchange of gases will occur at the alveolar site and at the tissue site. Now today in this topic, we are going to understand how the oxygen and carbon dioxide are transported via blood and in how many forms they are transported. So we are going to see in detail. So let's get started. And let me start the transport with the very first gas, that is carbon dioxide. I will tell you why I am going to teach carbon dioxide transport first. So there are two gases which will be transported, right? There are two gases. One is oxygen and one is carbon dioxide. So we are going to understand transport of carbon dioxide and transport of oxygen. So there are two gases, transport of gases. We are going to understand the transport of carbon dioxide and transport of oxygen. Now first of all, let me tell you what is the medium of transport. So the medium of transport is the blood, right? What is transporting all the things in the body is the blood, right? So what is the composition of the blood? You must be knowing the composition of the blood. In the blood, who is going to help us with the transport of gases? The plasma is going to help us, which is 55% in the blood. And among the formed elements, RBC is going to help us in the transport of gases. So there are two things which are going to help us in the transport of gases. One is plasma and another is RBC. Why RBC? Because in the RBC, there's a very nice thing in the RBC and that is hemoglobin. Hemoglobin is taking all the space inside the RBC and that is what the purpose of hemoglobin and purpose of RBC. Hemoglobin has sites for the, hemoglobin is basically a vehicle for the transport of oxygen and carbon dioxide. Most of the oxygen, it is transported along with the hemoglobin. You will see that, right? So we have two things, one is plasma and one is RBC. Now transport of carbon dioxide occurs in three forms, whereas transport of oxygen occurs in two forms. So these are the basic differences. In what three forms? Let me tell you all the three forms. One is dissolved form. I have told you in the lecture exchange of gases that it depends upon the solubility, the rate of diffusion, right? Here also how much gas is solubilized, that also depends upon the solubility. How much gas will be dissolved in the blood, it depends upon its solubility, and I have already told you carbon dioxide has more solubility. So that is why in dissolved form it is going to be transported how much percent? 7%. From total carbon dioxide, 7% is going as dissolved form. 7% is going as dissolved form. Now the another form is bicarbonate ion form. Bicarbonate ion form. What is bicarbonate ion? HCO3 negative. How it will be formed? I am going to tell you. Right. Then how much percent? 70%. 70% is going to travel as the bicarbonate ion form. So when it is dissolved, that means it is dissolved in the fluid part of the blood. And what is the fluid part of the blood? Plasma. So the 7% and this bicarbonate ion form also 70%, both the forms are going to travel via the plasma. Both the forms are going to travel via the plasma. So total how much percent of CO2? 70 plus 77%. Total 77% CO2 is traveling via plasma, and rest 23% CO2 is going to travel in the form of carb-amino-hemoglobin. What is this carb-amino-hemoglobin? When carbon dioxide, when it goes and binds with the hemoglobin, then it makes this compound that is carb-amino-hemoglobin. Why this is known as carb-amino-hemoglobin? Because where it binds in that site, amino group is there. In the hemoglobin, amino group is there in that site where CO2 binds, right? That is why it is known as carb-amino-hemoglobin. So, how much percentage of CO2 travels in this form? 23%. And it will obviously, hemoglobin as it is present in the RBC, it is going to travel via the RBC. Via RBC, right? Via RBC, and 77% is going to travel via plasma. Now, if we talk about the two forms of oxygen, then oxygen travels in the form of dissolved form in plasma. How much dissolved form? Only 3%. Only 3%. Obviously, through the plasma, via plasma. But, so you know the difference. Here 3% dissolved form, here 7%. Why more? Why it is more here? Because here, you know, the solubility of CO2 is more, 20 to 25 times more than the solubility of oxygen, right? So now the another form is known as oxyhemoglobin form. Oxyhemoglobin form. Oxyhemoglobin is a compound which is formed when oxygen binds with the hemoglobin, right? So I will tell you how many oxygen can bind with one hemoglobin molecule. One hemoglobin molecule has 4 sites for oxygen. So 4 oxygen can bind to one hemoglobin molecule, right? This is, and then it will form oxyhemoglobin, right? So now, first of all, we are going to discuss the transport of CO2. From where the transport of CO2 will start? Transport of CO2 will start from the tissues, obviously, because at the tissues only, the CO2 is getting released. That is why partial pressure of CO2 is more here and partial pressure of oxygen is less here. Near to the tissues, there will be blood capillary. Let us suppose this is the blood capillary. In the blood capillary, who will do our help in the transport of CO2 and transport of oxygen? Plasma. So this is the plasma in the blood capillary, and this cell is RBC. Why I have made it this much broad? Why I have made it this much large? Because inside this, what is happening, I need to tell you, right? That is why. So now this is RBC and this is plasma, and this is a blood capillary. So inside the blood capillary, there is plasma and there is RBC. These two things will help us in the transport, right? From the tissues, the journey of the CO2 will start, and at the alveoli, the journey of CO2 will end, right? So, how it will occur? I have told you this CO2, 7% it comes and gets dissolved in the plasma. Now I am going to tell you very interesting thing, that is 70% of CO2 is going to come into the RBC and it is going to react with water to form H2CO3. What is this? This is carbonic acid, and this reaction will occur in presence of one enzyme, that is carbonic anhydrase. This is an enzyme which is present inside the RBC in maximum amount. Outside the RBC also this is present in plasma, but in less amount. That is why this reaction is occurring inside the RBC, because more amount of carbonic anhydrase is present inside the RBC. What is Ca? What is this Ca? This is carbonic anhydrase. Carbonic anhydrase. Right? Now, so what will happen further to this carbonic acid? It is going to dissociate into H plus and HCO3 negative. This is the bicarbonate ion formation. H plus is hydrogen ion, HCO3 negative is bicarbonate ion. I have told you previously, CO2 will be traveling in three forms: dissolved form, bicarbonate ion form. So we have seen the dissolved form and we have also seen the bicarbonate ion formation. But I have told you bicarbonate will travel through the plasma. So it has to now come out of the RBC. Let us throw it out, right? This is the bicarbonate ion, right? This is the bicarbonate ion. It will come out in the plasma. This is the plasma. It is coming out in the plasma. Now when it will come out in the plasma, it will bind with either sodium or potassium, mostly with sodium, and it will stay here in the plasma in the form of sodium bicarbonate or potassium bicarbonate, right? Now when a negative ion from the RBC is coming out, then another negative ion from the plasma will enter into the RBC to maintain the ionic balance. When one ion is going out, then another ion has to come in. When negative ion is going out, negative ion only has to come in the RBC. So when bicarbonate ion will go out, then chloride ion will come in, because this is also a negative ion, and this is known as chloride shift. Very important phenomena. Chloride shift, also known as Hamburger phenomena. Hamburger phenomena. Are you hungry now? Are you hungry after listening to the hamburgers phenomena? Okay. So after the class you can eat. So now, hamburgers phenomena or chloride shift, that is happening. So now you have seen 70% of the CO2 has come outside in the plasma in the form of bicarbonate ion. Rest of the 23% is still left. Rest of the 23% CO2 is also going to come inside the RBC. It will meet hemoglobin and it will ask hemoglobin, can you take me with you till the alveoli? So yes, obviously, the hemoglobin will bind the CO2 with it and it will form HbCO2, or you can say carb amino hemoglobin. I have already told you the name of this compound, carb amino hemoglobin. Now, see, somebody is feeling lonely here. Who is that? That is this hydrogen. This hydrogen is feeling lonely here. So this hydrogen and rest of the hemoglobin, lots and lots of hemoglobin is there inside the RBC. This hemoglobin will not let this hydrogen be present alone. So it will bind with it and it will make one compound that is known as HHB. This HHB is known as hemoglobinic acid. Hemoglobinic acid. That's what happened. That's what happened in the tissues. Near to the tissues, this is going to happen. In the tissues, which type of blood is coming, beta? Oxygenated blood. In the oxygenated blood, partial pressure of CO2 is how much? In the oxygenated blood, partial pressure of CO2 is 40. In the tissues, partial pressure of CO2 is 45. Where it is high, here. Where it is low, here. That is why all the CO2 is coming here. But once all the CO2 will be lowered here, will get lowered here, then this blood will become deoxygenated blood. In this deoxygenated blood, now what is more? Carbon dioxide is more. Now this deoxygenated blood has to leave all the carbon dioxide. Where it will go? To the lungs. For that purpose, it will go to the lungs. So here it goes to the lungs. This is the same blood I am making. This is the same blood I am making. This is the same blood vessel. In the blood vessel, there is plasma, there is RBC. This is plasma and this is RBC, right? This big cell is RBC. Now, this blood has reached near to the alveoli. Let us make here alveoli. This is the alveoli, beta. What is this? This is alveoli. In the alveoli, partial pressure of oxygen is high and in the alveoli, partial pressure of CO2 is low. And the blood which is coming here is deoxygenated blood, in which partial pressure of CO2 is high. So, definitely from here to here, the CO2 will diffuse. It will go, right? So, now how it will go? See, the 7% CO2 was present in the dissolved form. It will easily go because of the difference in the partial pressure. This 7% will easily go into the alveoli. Now, let us talk about this 70% HCO3 negative. How much HCO3 negative was present? 70%. This 70% HCO3 negative will now go inside and it will look for its friend, that is H plus. But H plus has already made another friend. H plus has already made another friend, that is hemoglobin, and it is sitting with the hemoglobin. Here it is. Here this HB is there. And so this was the 70%. When it will come inside, now it has to get hydrogen. Then only this reaction will occur in the reverse direction. Right? I will show you that reaction now. Now, where is this 23% CO2? 23% CO2 is also present inside the RBC in the form of HbCO2 form. Right. Now, there is a very important role played by oxygen here. Where is the oxygen? Here is the oxygen. Oxygen is high in the alveoli. When the oxygen from the alveoli, it will come into the deoxygenated blood. This is the deoxygenated blood which is coming near to the alveoli. In the deoxygenated blood, oxygen partial pressure is less. How much it is? 40. And in the alveoli, how much oxygen? 104 mm of Hg is the partial pressure. So, from there to here, oxygen is going to come. This oxygen is going to come inside and it will lead to the formation of very important compound HbO2, oxyhemoglobin. This oxyhemoglobin formation will lead to the release of H plus as well as it will lead to the release of 23% CO2 which will go here. The 23% CO2 will go here like this. Right? Now, the H plus has come. Now, the HCO3 negative is very happy to see the H plus. Now, this H plus will go to the HCO3 negative and the reaction will occur again in presence of carbonic anhydrase in the reverse direction. There is formation of H2CO3. Then further it will dissociate in again the presence of carbonic anhydrase. You have seen here the reaction has occurred in the forward direction. CO2 plus H2O in presence of carbonic anhydrase has formed H2CO3. Further in presence of carbonic anhydrase, it has dissociated in H plus and HCO3 negative. Now the reaction is occurring in a reverse direction. HCO3 negative combines with H plus. Here is the release of the H plus after the formation of HbO2. And when this H plus will come, carbonic acid will be formed and then again it will dissociate into water and CO2. Then this 70% CO2 is going to release out. So this 7% is released out, 70% and 23%. All the 100% CO2 is being now unloaded into the alveoli. When the blood will give all the CO2 and it has already taken the oxygen, now this blood will become oxygenated blood. I hope you have understood all this. Okay, one more thing here. You have seen that this bicarbonate ion, when it has come inside, then who is sitting inside? Chloride ion. It has to go out. and this is known as reverse of chloride shift. This is known as reverse of chloride shift. Very important. So you have to remember chloride shift is taking place at tissue level. Reverse of chloride shift is taking place at alveolar level. Right? At the tissue level, you have seen the formation of carb amino hemoglobin, whereas at the alveolar level, you have seen the formation of oxyhemoglobin. This oxyhemoglobin, it is playing a very important role. This oxyhemoglobin HbO2, it plays a very important role in the removal of CO2 from the deoxygenated blood to the alveoli. And this effect has a name that is known as Haldane's effect. This is known as Haldane's effect. So what is this Haldane's effect? This is the effect of formation of HbO2. This is the effect of formation of HbO2 on the transport of CO2 from blood to alveoli. I hope you have understood the very important concept of Haldane's effect. If you have understood this topic, then one more thing is there for the Haldane's effect. It is opposite of one effect that is known as Bohr's effect. I will explain you how it is opposite of Bohr's effect. It is opposite to Bohr's effect. Where you will see Bohr's effect, you will see this effect at the tissues. When the CO2 is more, when the partial pressure of CO2 is more, then it will lead to the formation of HbCO2 and it will lead to the dissociation of HbO2. That is Bohr's effect. So obviously, Haldane's effect is taking place at alveolar site. Bohr's effect is taking place at tissue site. In case of Bohr's effect, there is dissociation of oxyhemoglobin. In case of Haldane's effect, there is association of oxygen and hemoglobin. So hence, they both are opposite. So you have understood Haldane's effect, right? You have understood Bohr's effect, and this is the end of the transport of CO2. In the another part, we will discuss about the transport of oxygen. So stay tuned for the transport of oxygen, because then only the transport of gases will be completed. Thank you.